Hello everyone. Today we'll be understanding FP algorithm and its Python implementation. The FP algorithm, which is frequent pattern growth algorithm, it is an efficient method for mining frequent item sets without generating candidate item sets like the a priori algorithm. It uses a compact data structure called the FP tree, which is frequent pattern tree, to store transactions and extract patterns. Five key steps to generate frequent patterns are: count frequent one item sets, sort transactions in descending order of support, build the FP tree, generate conditional pattern bases, and draw FP tree.
Today we are explaining line by line detailed explanation of our FP growth implementation. So first of all, we are importing required libraries like this is we are importing pandas which is used for data manipulation and reading the data set. Next we import default dict and counter which is used for store and count item occurrences efficiently. Then we import OS library, which is used for modify system path if needed, and then digraph, which is used for visualize the FP tree, which is output for this algorithm. And next we import files, which is used to handle files upload in Google Colab. Next, this code is used for uploading and reading dataset, and this also. Next, we are defining the tree node class, and which is basically used for FP tree node. So this is F a tree node class, and these are constructor for this class. So one by one we are explaining each parameter. So the item is stored in the node, and the count, the frequency of item in transaction, the parent pointer to the parent node, and children, a dictionary storing child nodes, and link used to connect nodes of same item in the different branches. So further, this is add child function which is used for adding child nodes to the tree. So if child node does not exist, it is created and added to the self children. Next,
So here we will be creating a tree structure. In this we will be defining the FP tree constructor which takes of two parameters, one the self and next the minimum support. So for the self dot root, the FP tree starts with a dummy root node. The self header, a dictionary that stores links to all occurrence of an item in the tree, and this min support, it stores the minimum support threshold. Now adding this function, it manages all the transactions. It is basically used to adding the transactions to the FP tree. It also takes three inputs. First the current node, which refers to the current node itself. It iterates through the transaction items, add each item as a child node to the FP tree, and increments the counter node. As you can see here, it is incrementing the counter. It updates the header table with the new item node. Now the display function, it is basically used for visualizing the FP tree, as you can see further in the output section. Now, the basically we are using this graphics library which we are imported in the beginning for the visualization purpose. Now, here we are creating a root node, so which recursively adds. You can see here as we are adding the all the children to the root node, so it recursively adds the child nodes and connects them to the parents. It generates a graph representation of the FP tree. As you can see here, it is returning a graph which will display in the output section. So the function which is responsible for displaying our output is this function. Now the now next function will be our count frequent set items. So it basically takes two parameters as its input. First one is the transactions and next be the minimum support. So it basically counts the occurrences of each item in all the transactions. As you know that the counting the frequent items is one of the most important step of our FP tree algorithm. So this step is basically critical. Now it filters item with support with which have a support greater than equal to the minimum support count, as you can see here. Now the next function, which is the sort transaction functions, it takes two inputs, that is the transaction and the frequent items. So it is basically used for sorting the transactions by item the frequency. So firstly we are ordering, the sorted function is basically used for ordering item based on their frequency. As you can see here, we are using this function for frequency. Now in the descending order, as you can see here, this is basically used to sort the items in the descending order, and then it assigns rank to all the items that are present in the transactions. So this list is basically used to maintain a list of all the sorted transactions. Now moving further, you can see the sort items within each transaction, some based on some frequency. As you can see here, the implementation of this function. Now next function will be our build fp3 function. It basically takes two parameters as its input. First one be the sorted transaction, and next be the minimum support. So it builds the FP tree from all the sorted transactions and saves the visualization of the FP tree by taking the minimum support count into consideration. Now, as you can see here, it generates a output in the form of a PNG. As you can see, you can also use here JPG if you want, or JPEG if you want, as per your considerations. But here for our need, we are using PNG.
After the execution of this build fp3 function, we'll get the dialog box like this. with this with this choose files icon, we have to choose the transaction e-commerce data set. After choosing this e-commerce data set, our all the functions which are used to create the fp3 will get implemented, and our fp3 which will be generated as an image will come here like this, and this fp3 image will show all the relationships of the fp3 diagram. Now, for generating conditional FP3, we'll be having pattern, which is the dictionary to store conditional FP3 for each item. This function generate conditional pattern is taking two parameter, which are FP3 and min support. For four item in FP3 header tables keys. This is used to iterate over each item in the header table. This conditional base is used to have the list to store conditional pattern bases. This loop for node in FP3 header table item. It is used to iterate over each node of the current item. This path is used to store the path prefix leading to the node. This parent equals to node dot parent is used to start from the parent of the node, while parent and node parent dot item not equal to root. It is used to traverse up the root. Path dot append parent dot item, it is used to append item to the path. This next line, parent equal to parent dot parent, is used to move up to the tree. Path dot reverse is used to reverse to get the correct order. This conditional base append path comma node dot count is used to store path with its count. This function iterates over all items in the header table of the fp3. For each item, it constructs a conditional pattern base which is path in the fp3 leading to the item. For example, these, as you can see, these arrows, this represent the path. These path traversal these this path traversal moves from node up to the root. It reverses the path to maintain order. The result is a list of path and their counts of each item. Next next function is mind tree, which takes parameter which are fp3 prefix frequent pattern and min support. This function is used for mining the frequent pattern. This loop for item comma nodes in item is used to iterate over all items in ascending order. This next line, next pattern is equal to prefix dot copy, is used to copy prefix set. New pattern dot add item is used to add current item to pattern. Next, support equals to sum node dot count for node in nodes is used to compute total support of the pattern. Next line, frequent pattern frozen set new pattern equals to store is equals to support is used to store the pattern. This entire function sorts item based on their total support count in ascending order. For each item, a new frequent pattern is generated. It copies the current prefix and adds the item. Computes total support for the item across nodes. If support if support is greater than min support, then the pattern is stored, which is used for with generating the FP tree. Now, this next function, generate frequent patterns, is taking two parameters, which is FP tree and min support. This frequent pattern dictionary is used to store the patterns. This this function return frequent patterns which will be used to generate the FP tree. This entire function generate frequent patterns creates an empty dictionary to store frequent item sets. It calls mine tree recursively to extract patterns. Then it returns the frequent item sets with their support values. Now, the next part of the code is used for data pre-processing. This line dataset is equals to dataset drop is used to remove unnecessary columns like description, quantity, invoice data that are irrelevant for pattern mining. This function dropna function is used to remove the missing values in the dataset. Next part of the code is used to convert transaction to list of lists. Here, it groups transaction by invoice number. It groups transaction by invoice number, which is given in this line. Then it extracts stock code items into list, and then it converts transaction into list, which is given in this line of the code. Next part of the code is used to set minimum support and execute parts which are mentioned above. It sets minimum count equals to 2, which is given here, and then it executes the following steps, which are: first, count frequent items. Then it executes sort transactions. Then it executes build FP tree. Then it executes generate conditional patterns. Then it executes generate frequent patterns, and all these functions have been discussed above. Next part of the code is displaying frequent patterns. After the execution of all the functions that have been explained above, we'll iterate over all the mind patterns in this line and then print frequent item sets with their support counts. Now, this is the final output of the code. Here, all those items which are having frequency more than the support count of 2 are listed. Then we'll be getting the all those patterns which are mined using FP algorithm with their support. This and the summary of the code is this Python code implements the FP growth algorithm for mining frequent patterns efficiently. It pre-processes data by removing irrelevant columns and grouping transaction. It counts frequent one item sets and filters based on minimum support. It sorts transactions by item frequency for consistency. It builds an FP tree to store transactions compactly. It generates conditional FP trees for recursive pattern mining. It mines frequent item sets using recursive traversal, and it displays results with frequent patterns and support values, which is given here. All these are the frequent patterns which are generating using FP algorithm, and this is the output. This FP tree output is the tree which is generated with the help of this code. This tree. I hope you like this video.